In this video, we're going to be talking about an introduction to inequalities. And first, we're going to start off with the different ways that you may see notations written for inequalities. So in general, this is an inequality saying x is less than a. This entire, what we call set builder notation, says the set, so that's what the squiggly brackets mean, they're braces, of x's such that x is less than a. If we were to graph this on a number line, we'd have this value a, and we want everything that's less than that number. So all of these values less than whatever that number is, and we're going to use a parenthesis to show that it is not including the value a itself. You may also see it written with an open dot. So if again I had a number line, I could use an open dot to show everything less than a, not including a. So parentheses and open circles mean not including the value itself. You may also see it written in interval notation. This says all the values, not including negative infinity, because negative infinity is not a number, but all the values going down forever up to a, not including that value. So again, this is the same thing. All the values less than a. If I want all the values greater than a, I can draw a number line. Wherever that value a is, I want everything greater than, so everything getting bigger. And again, I'm not including it, so I'm going to use a parenthesis. You may also see it with the open circle. If I said everything less than a certain value a, but equal to, so this straight bar down here says less than or equal to. So now we are including whatever that number, that value a is, in our set, in our answers. So everything less than, now I'm going to use a bracket instead of a parenthesis, and everything less than that value. If you see a bracket, that's the same thing as a closed dot. So a bracket, bracket, a closed dot, those mean that we are including that value in our answer. So parentheses, open dot means you're not including that value. Brackets, closed dot, or sorry, open dot over there. Brackets and closed dot mean you are including that value in your final set. So again, that set builder notation says the set of x's, that straight bar says such that x is less than or equal to a. In the interval notation, we're saying all the values down from negative infinity. So again, negative infinity is not a number. It's just going down forever and then up to that value and including that in our answer. And if I wanted to do this next one here, I have all the x's such that x is greater than or equal to a. So again, that bar means I'm including a in my solution. So wherever that value a is, I'm going to use a bracket. I'm going to go up forever, which is exactly what the interval notation says, of starting at a and going up forever in the direction of infinity. Now these next graphs down here, they're showing closed intervals. So these go on and on and on forever in both directions, either going less than or greater than. So all the values, all the numbers going down in the negative direction, or all the values going up. These are closed. It's within a set range, so in between two values. And then we just have to decide, is it including that value where it stops or not including it? So again, if it's strictly less than or greater than, with no bar, you're not including it. And down here we have that less than or equal to, so we have the bar here, which is saying we are including that in our answers. And the same thing over here. The reason I like to use the parentheses and the brackets is because that's how we would write it in the interval notation versus the open dot and closed dot. But I believe your homework will probably use the open dot and closed dot. But I like to use the parentheses and brackets because that's how I would write it in the interval notation as well. So again, if I'm not including it, I use parentheses. If I'm including the value, I use the brackets. So this first example here with the closed interval says we have these two values a and b, and our x is a set of all x's such that a is less than x less than b, meaning x is greater than a and x is less than b. So it's all the numbers between a and b. And since I'm not including those values, I would use parentheses, but everything in between my a and b. The next one here says I'm including them, so I would use brackets for both. I'm including a and b in my solution set. The next one says I'm not including a, so I use a parenthesis. I am including b, I use a bracket, and all the numbers in between are part of my solution. And then this last one here says I am including a, I'm not including b, and I want all the values between a and b. And again, the same thing in the interval notation. I have a bracket on the left, parenthesis on the right. I'm including a, I'm not including b. The line says I'm including a, no line says I'm not including b. Alright, so the solution to an inequality is the set of all the numbers that make that inequality true. So this first example here, we want to decide whether or not the numbers given are a solution. So this first example says circle the values that are a solution to the set x greater than -3. So if we draw a number line, we can visualize the solution. So I have my number line, have a -3 here, and as we go to the right, the numbers get bigger, so they're getting closer to 0, and as we go left, they're getting smaller, so we're getting more and more negative. So I'm looking at this -3, and I want all the values greater than, so greater than -3. And the way I think about this is there's this little, because it's easy to flip-flop them. So I imagine a little Pac-Man guy, and he's always eating the bigger number. So we can see the mouth here is open towards the bigger number. So x is greater than -3. If it was facing the other way, then the -3 would be bigger and x would be less. So I know this says x is greater than -3. I want all the values from 3 up that are getting bigger. And I'm not including that, so it's going to be with a parenthesis here. So that's just if I wanted to graph it. So now I have this number line. I can visualize if it's in this blue shaded region, that's a solution. These are all the values greater than -3. If it's not shaded, it's not in the solution. It's not greater than -3. So looking at this first one, it says -3. Well, is -3 greater than itself? No, it's not. So that's not part of my solution. Is 0 greater than -3? Well, if I follow my number line up to the right, here, 0 would be here. 0 is in fact greater than -3. So that's part of the solution. What about -1? We see here, this is greater than -3. That's part of my solution. -5. Nope, that's left of -3, and left is less. So -5 is less than -3. It is not part of my solution set. And then 7, well, if I'm going up, I go -3, -2, -1, 0, and then 1, 2, 3, 4, 5, 6, 7. So 7 will be part of my solution set. Why don't you try the next one? Alright, let's see how you did. So I'm going to go ahead and draw a number line again because I'm a visual person. You don't have to. So I have 0 here. And so left is going to get smaller. So -1, -2, -3. Right is going to get bigger. That's the way we always draw number lines. So as I move to the right, my numbers are getting bigger. I want to know first, is -3 less than or equal to 0? So now we are including 0 in our solution. So I'm going to use a bracket or a closed dot. And I want everything less than. So left is less. And again, I can tell that the open mouth of my inequality is facing that 0. So this is the bigger side. So x is the less side. So x less than or equal to 0. All the numbers going less, left on my number line. So is -3 less than 0? Yes, it is. Is 0 less than or equal to 0? Well, it's not less than, but it is equal. 0 equals 0. So 0 is also part of our solution set. We can tell with the bracket we have included it in our solution set. 4, is 4 less than or equal to 0? Nope, it's bigger. -5. Well, if I continued my number line, I'd go -1, -2, -3, -4, -5. So yes, that's going to be less than 0. And then 7, well, 7 is going to keep going up to the right, so no, 7 is not less than 0.